Hello everyone, welcome to my talk at the SIGRE Australian Technical Committee Seminar 2020. In this presentation, I'll give you an update on the work done by SIGRE Australian Panel D1 in the last 12 months, and also give you an update on the activities of the SIGRE International Study Committee D1. If you have any questions regarding the content of this presentation, please send me an email. You can find my email address at the bottom of this page. Basically, Study Committee D1 works in the areas of testing techniques and the materials for electric power systems. It's a horizontal committee that usually works on solutions that can be used as inputs to the work of other study committees. But D1 also works together with other study committees on problems of a particular equipment or systems. Since D1's testing work is mainly focused on electrical insulation systems, where insulating materials are always a critical part of the systems, it is then logical to have the testing as well as materials in the scope of D1's work. As you can see below, our work in the materials area covers gaseous, liquid, and solid materials. We are continuing to work on traditional materials such as SF6, mineral oils, epoxy resins, XLPE, but also on development of new materials such as SF6 replacement gases, vegetable oils for power transformer insulation, and nanopolymer composite for insulator applications. We would investigate properties of these materials such as dielectric strength, thermal conductivity, aging properties, resistance to PD, and their performances under different voltage stresses such as AC, DC, impulse voltages, and sometimes with a combination of them. In conjunction with developing knowledge in materials, we work on testing techniques such as online PD monitoring and expert systems, dissolved gas sensors, and also laboratory testing techniques such as impulse voltage testing, fast transient voltage testing, and testing with combined voltages. Apart from producing inputs to the work of other secret study committees, D1 also provides information to standard development work, usually in response to requests from IEC technical committees. So D1 has extensive connections with IEC technical committees on a range of apparatus such as rotating machines and power transformers, on materials, and on testing techniques. So that's a quick coverage of Study Committee D1's scope of work. First, I will give you an overview of the work areas of Study Committee D1 in general. This is a chart of the current D1 international working groups being put into 4 different areas. We can see that the working groups are either on new materials, new techniques, or on applications of traditional materials techniques to new areas or new devices. In gaseous materials, we can see a working group on non-SF6 gases and a working group on dielectric testing of gas-insulated HVDC systems. In liquids, we see a working group on ester fluids, which I think includes synthetic and natural vegetable oils. In solids, we see a working group on performance of polymers under combined stress of DC and AC voltages, and a working group on nanostructured dielectric materials. In the testing category, we see work is still being done in traditional areas such as atmospheric correction for high voltage testing and insulation design, and also on new testing areas such as partial discharge detection under DC stress, measurement of very fast transient, and testing superconducting systems. So this chart here reflects very well the D1's scope of work. Now let's look at the technical brochures published by D1 working groups and joint working groups in the last 12 months. Two technical brochures have been published in the last 12 months. TB 794 published in March this year is on field grading in insulation systems. Field grading is critical to many high voltage equipment. It's basically used to modify electric field distribution within insulation systems by using different materials and shaping of the insulation structures. It's a very old technique, but it's being used increasingly with new materials. And the technical brochure provides a very extensive coverage of this topic. TB 783 published in October last year by a joint D1 and A2 working group is on dissolved gas analysis monitoring systems. It focuses on online DGA techniques used for monitoring gases from degradation of oil paper insulation in power transformers. It talks about types of monitors on the market and their costs and the benefits, and also provides a review of accuracies that can be achieved using different techniques. Let's move on to activities of Australian Panel D1. D1 held a virtual meeting on the 9th of July this year. Below are some of the presentations on activities and member organizations. These include research projects at the universities on new materials and new testing techniques, field experience on monitoring and diagnostics at utility plants, and the new testing capabilities of testing laboratories. The top picture shows the UNSW's novel power line monitoring system that was undergoing high voltage and high current test. The photo in the middle shows high voltage bushings being tested for partial discharges using current transformer sensors. The bottom picture shows the optical sensor system developed at the University of Queensland for monitoring conditions of power transformers. From these presentations, we can see that a wide range of activities are being conducted at member organizations. AUD1 members also presented 3 papers at the C-Grade 2020 E-session. A picture from each of the papers is showing on the right. AUD1 members also continue to participate in the work of international working groups. The topics they are working on are listed here. Here is a list of AUD1 member organizations and their representatives. We can see it includes power utilities, universities, power equipment manufacturers, test equipment suppliers, and test service providers. Thank you for coming to my presentation. Please send me email if you have any question.